So before we talk about linear functions or linear relationships and linear equations, what we need to understand is that the basis behind a linear equation is the slope. It is this idea that we have a constant rate of change, and that is what creates a graph with a straight line. So in this first video, we're going to talk about calculating the slope or the rate of change once we already know the relationship is linear of a table and of two coordinates. So there are a couple ways to do the two coordinates. I'm trying to relate everything together. So the way we do two coordinates is going to be extremely similar to the way we do a table. So like usual, I have got steps that we will go through in order to find the rate of change. And I'll go over this one example that you'll take notes on, and then I'll go over a couple more examples that you can just watch or pause the video and try and find yourself and then check along with me. So my first step is to find the change in y. So what we want to remember is when we're looking at a table, my table is laid out as x, y. That's the same way when we're talking about coordinates, and it's the same way when you're saying the alphabet. It's in alphabetical order. So if my table isn't already labeled x, y, I need to do that. So notice I said that the first step is to find the change in y, and that will make sense for step number 3. So the change in y here, what I can do in order to figure out how much I'm increasing from 17 to 41, I'm adding something, right? Because 17 is smaller than 41. I can do subtraction, and I can say, okay, 41 minus 17 is 24. So 17 plus 24 gives me 41. So that was my change in y. The second step is to find the change in x. So when I'm looking at this, my change in x is a little bit easier to see on my own. I have to add 6 to go from 2 to 8. And I already know that this is a linear function, so I don't have to keep going. My ratio for my change of y and my change of x is going to remain constant, so I just have to do it with the first two coordinates. So I'm going to just put a little highlighted box so we understand that we're just focusing in here. Then I'm going to write it as a fraction, the change in y over the change in x. And I want to include this sign. So I know I'm doing my change in y, which is plus 24, over my change in x, which we said is plus 6. Then I'm going to simplify. So when both the signs are positive, that's just a positive divided by a positive. So I'm going to get a positive number. So I know that my slope is going to be positive. And then I can simplify this fraction by doing division by the greatest common multiple. So the greatest common factor is 6. So I can divide both of these by 6. And that gives me 4 over 1. When we are interpreting what this means, you're interpreting it as units of y per unit of x. So in this situation, we're saying this amount of water per amount of time. So what is happening is we are increasing by 4 liters, because that's my top number and that is my y. So interpret as units of y. So we're increasing by 4 liters per 1 minute. So that's kind of our way to interpret what this slope means. We're thinking units of y per unit of x. So let's just do a couple more examples following those same steps. So my first step is to do the change in y. My change in y from -3 to 3 is +6. My change in x from -1 to 2 is +3. I'm going to write this as a fraction as the change in y over the change in x. And then I'm going to simplify. And 2 over 1 is the same thing as 2, so I don't even need that 1. Let's do one more. So my change in x and my change in y, sorry, I need to go in our same order. My change in y is -3. My change in x is +1. Let me do it in the proper color. So I'm going to put my change in y over my change in x. So I'm going to get -3 over +1, which is going to give me a negative slope because it's a negative divided by a positive, and it can just be -3. I know I said one more, but let's do this one because this one is going to give us an interesting slope. So my first step is to find my change in y. This change in y is +0 because I'm going 0 units up or 0 units down. There's no change in y. My change in x is +1. I'm going to write my change in y over my change in x. And what I'm going to remember is that when 0 is divided by something, so if I type into my calculator 0 divided by 1, it's just 0. So the slope of this graph is 0. And when we have 0 slope, that just creates a horizontal line. So what we would look at for that is just this. We've got a slope of 0. We have a horizontal line because our numerator was 0 and our denominator is 2. So that's how we find the rate of change or the slope of a table. It's going to be really similar when we're doing coordinates. So let's look at these steps. So my first step is to label each coordinate x, comma, y. So when they give you the coordinates in the problem, you're going to label them x and y, both of them. So a really common way of asking this problem is what is the slope of a line that has a y-intercept of -1.5 and contains the point 7, 2. So this is in disguise because it is actually giving us 2 coordinates. It's just not writing out the y-intercept as a coordinate. But I know the y-intercept has an x value of 0 because it's on the y-axis. So my 2 coordinates in this scenario, we have an x of 0 because it's a y-intercept. And then we have this other point. And we're going to label these x, y, x, y. My second step is to create our own little table. So you can also use the slope formula. The reason I like creating the table is it allows us to do the formula without getting confused at 1, memorizing a formula, and 2, remembering when we're adding and subtracting and having to put numbers in the correct spots. So this is just my little shortcut. So what I'm going to do once I create my table is I'm going to put 1 coordinate in each row. So I drew the outline of my little table. It's always going to be the same. It's going to look like this. And then I'm going to put one coordinate in the top row and one coordinate in the bottom row. So I'm going to put 0, negative 1.5, and I'm going to put 7, 2. And that's kind of why we've labeled it X and Y, so I could remember that's what's going in the table. Then I'm just going to follow my steps for finding the slope of the table. I'm going to find my change in Y. My change in Y from negative 1.5 to 2 is plus 3.5. Then I'm going to find my change in X, which is plus 7. Then I'm going to write this as a fraction. We're going to write it as our change in Y over our change in X. I don't like when my slope has a decimal in it because it's already a fraction. So when we're simplifying this one, we're actually going to just multiply by 2 so that we do not have a fraction. And I'll see that, or sorry, we don't have a decimal. I'll see that it's 7/14. And so I know this reduces down to 1/2. Both of them were positive, so we've just got a positive in the end. So my slope of the line that has a y-intercept of negative 1.5 and contains the 0.72 is 1/2. So let's just do one more problem. Let's look at this one. My first step is to label my coordinates x, y, x, y. I'm going to draw a table. I'm going to plug in my numbers into the table. So I've got 1, negative 3, and 4, 2. I'm going to find my change in y. Negative 3 to 2 is positive, or plus 5. I'm going to find my change in x, which is plus 3. And I'm going to do my change in y over my change in x. And I'm going to simplify. This is as simple as it can go, so that is my slope. So we actually have time for one more. I really like this one, but not as much as I like this one. So let's label this x, y, x, y. I'm going to draw my table. Sorry, it's going to be kind of tiny. I'm going to write in my coordinates, negative 8 and 2, negative 8 and negative 2. And I'm going to change my, I'm going to find my change in y. From 2 to negative 2, we're actually going down 4. We're decreasing by 4. And from negative 8 to negative 8, I'm increasing 0. I'm going to put my change in y over my change in x. What happens here is we are dividing by 0. You cannot divide by 0. If you type that into your calculator, you'll get an error message. So since there's an error message, we're dividing by 0, we know that this slope is undefined. So instead of having a number, you're just going to write undefined. So what that would look like is a vertical line. So before we were working with the slope of 0, which was our horizontal line, but an undefined slope when the denominator is 0, we've got a vertical line.